Did you wake up to a sight like this? That was the sun this morning in partial eclipse over Peterborough. We have the best of your images from the UK and from space on the show tonight.
Plus, we have exclusively a never-before-seen image of our nearest neighbour, the Andromeda Galaxy. I'm Brian Cox, he's Dara O'Brien, this is Stargazing Live.
Welcome back to Jodrell Bank Observatory, another night of live stargazing. We've had an amazing response, by the way, from you. We've had hundreds of images and thousands of questions, so do keep them coming.
Yeah, no, yesterday we took a tour of the solar system and we got a wonderful first-hand look at Jupiter. And it was astonishing, wasn't it?
Astonishing, yeah. Thank you for all the notice that I looked like a garden gnome by not pushing down the top of my hat. But it was a lovely sight.
Well, I always found it beautiful. I mean, that telescope was beautiful. But the fact you can see the satellites, and I think you commented on the fact you can see the shadow of
one of the satellites going past Jupiter. It's incredible.
Yeah. Now, you know, after the programme finished, actually, the skies were clear here over Cheshire for about, 2 or 3 hours. So we turned the cameras on the skies and used that clear sky that's gone away tonight, full of cloud, to take these pictures of some of the constellations that you can see if you go out and the sky's clear. This is probably the easiest constellation to see. It's the Plough. Doesn't have the lines on it, of course, in the sky, so we can take them away. But it's made up of 1, 2, 3, 4, 5, 6, 7 bright stars. It's always visible in the northern hemisphere. But I think the next picture, which is the constellation of Taurus, which looks
exactly like a ball. Who could not see a ball in that?
That's here. It's these bright stars. But the interesting thing about Taurus is that if you look up to the right of it, you see this star cluster called the Pleiades, and that's not like the other constellations. It's like a mini Plough, actually. But all those stars are together in the sky. They're young stars that were born in the same place.
And always the easiest thing for you to spot in the sky is Orion, simply because there's a line of 3 and then there's another line of 3. There's a belt and a sword. It's always easy to find.
If we take the lines away, the most interesting star, I think, the star that could be shocking in our sky is this one, Betelgeuse or Betelgeuse. It's a red giant star. If you put it where the sun is, it will extend out to the orbit of Jupiter. It's enormous. It's very unstable. It's about to explode.
Now, give me the time scale for that.
The thing is, it could be tomorrow. It could be during this broadcast, and it would shine like a second sun in the sky because it's only 600 light years away. So that would be one of the most spectacular astronomical events ever. Might be in our lifetime. I hope so.
Okay, grand. Let's see if we can see anything at all at the moment. Let's go to Mark, who's outside.
Unfortunately, it's still cloudy. We've seen plenty of aircraft flying around, mind you, and if you want a part of the country that's got clear skies, then you can still pick out Jupiter, which is down in the southwest now, over to my left there. Now, last night we asked you to send in your pictures, and you didn't disappoint us. We've seen some fantastic images, and that's really cheered me up in a rather cold field in Macclesfield. Now, if you want to see more of these pictures or to add your own, you can join our photo group on our website. You can also join the live blog chat, and you can email us at stargazing@bbc.co.uk.
Okay, we have had loads of questions coming into us. Here's just a few of them to start off.
It's not like the trivial ones like, where is your height? Where's your hair greyer on the video than it is in the studio?
That was a question that we did get online,
yeah.
And no one knows. That is just one of those freaky things of nature. Is there more than one universe? Asked John White.
It's an interesting question. It depends what you mean by universe. I mean, universe could be everything that there is. And obviously we can only see the universe out to the edge of what we call the observable universe. So the universe is 13.75 billion years old. So by definition, we can only see things that are 13.75 billion years away, light years away when they emitted the light. But there are theories that there are other universes, there are theories there are other dimensions in space. So we live on a little sheet, a 3-dimensional sheet if you want, or a 4-dimensional sheet of space-time floating around, and there are other ones in this huge multiverse.
Okay, that's a huge question.
Well, that sounds crazy, by the way. We're testing it at the Large Hadron Collider. It's one of the things we might see at the Large Hadron Collider where I work.
Is some sort of proof of that?
Yeah,
okay. How do you know, as John rolls, how do you know what anything in the solar system is made of?
Well, you know what things are made of by looking at the light from them. It's the only way you can, unless you go and land there, so we've landed on some of the planets, but we know not only what the solar system is made of, but the most distant stars are made of, just by looking at the light and the signatures of the chemicals, of the elements that exist on those stars. And you can even look for oxygen in planetary atmospheres around other stars by looking at the light passing through the atmosphere. So, actually, talking of stars, today, the star, our star, is the star of the show, the sun. Obviously, it's impossible to see from here, because it's dark.
Yeah,
but luckily, we've got Liz Bonin standing by on the other side of the world in sunny Hawaii. Liz.
Thank you very much, Brian. Welcome to beautiful Hapuna Beach on the west coast of Hawaii's biggest island. It's a glorious morning here, and most importantly, the sun is out, which is very good news for this lot, because we've got a whole bunch of amateur astronomers who are just poised to capture you some stunning images of the sun. I'll also be talking to the top solar astronomer on the island, who's got some stonking images of our sun from Hawaii's highest active volcano. We'll see you in a bit.
Thank you very much, Liz. Now, this morning was the solar eclipse, a partial eclipse. Maybe you were looking to have clear skies. We were not in Jodrell here, I'm afraid. The sun rose about 8:30. I did, by the way, go online and say it would be 8 or 9:30. It would depend on how northern you are. I received a million replies going, I'm from Yorkshire, but I live in London. What time will my eclipse be happening at?
That's typical. I was going to say typical Yorkshireman, but I can't say that.
No, of course not.
But actually, it wasn't completely cloudy here, was it? This is the picture that we took from Macclesfield earlier today, early in the morning, and you can just about see the sun there, and you can see the shadow of the moon moving across the sun.
It's not bad. We have got better ones. We were sent better ones.
We've got some spectacular images sent in by viewers there, here. So that is a picture from Scotland of the eclipse. I think it's utterly, I mean, to think that that's our moon moving across the face of the sun, I still think it's beautiful. That's from Stuart Watt. We've got another picture, beautiful clear skies in Norfolk. Messed up by all this wildlife.
Yeah,
Happening around over the astronomy, but
you don't care about birds.
from Luke Broom in Norfolk. And this man, well, that's Cambridgeshire, again,
Yes.
same village. But actually, the thing was, as you mentioned, that the eclipse, quite strangely, I think, had already started by the time the sun rose in Britain.
So the sun was in eclipse, part of eclipse already. We can see,
Yeah.
I think, footage now from Warwickshire of this is the image of the sun coming out. Already
The eclipse
rising
had-
up.
well, it's already virtually at its fullest extent, actually, when the sun rose. So what you'd have to do if you wanted to see the full eclipse from start to finish is move east. So the sunrise was essentially earlier. And we got this picture sent from Israel. It's actually from an observatory in Israel, whose name I keep forgetting, the Barakat Observatory near Jerusalem. And this is a video image of the complete eclipse. You see the shadow of the moon moving across the face
That's
of
pretty
the sun.
phenomenal. However, I can't top that. We've also had exclusive images sent to us from the Proba 2 satellite in orbit, who sent us back these images. That's the sun, by the way, not
That's the sun.
vision. That's an X-ray, is it?
In ultraviolet light,
Ultraviolet,
I think.
okay. And there, that is incredible. That is.
I mean, that's the moon moving across the face of the very active sun, actually, at the moment from space. I think that's a spectacular image. All right, Dara. Well, we've seen the pictures.
Yeah.
Now, you wouldn't ask me a silly question.
I would
because
never
you've got a
do
degree
that.
in
I'm a trained
mathematics
man
and physics.
many years ago.
Even for the purposes of television, you wouldn't ask me something stupid.
Okay.
I know that. But you did ask a good question earlier, and I think we'll demo that.
Okay, Grant, you're the sun, this is the moon, my giant head is Earth, right? My famously large head will play the role of
People
Earth in
comment
this.
on your head
Yeah,
a
they
lot,
do a lot
don't
of it, but then I offer it up. Now, so in other words, what we saw was it passing slightly in front of it. This is my question, right? Right. This moves in a regular orbit around us in 1 month. Why is this not back here? Because the next one isn't until 2015. The next partial isn't for another 4 years. Why does it not happen every 28
Yeah,
years?
so a simplistic model, you would just think it passed by the same place every month.
Yeah.
Obviously, it doesn't. The reason is that the moon's orbit is inclined slightly to this line between the sun and the Earth. It's about 5 degrees. So, first of all, the moon doesn't orbit precisely in this plane. It orbits at an angle. But secondly, you as the Earth are orbiting around the sun. So
my
you
path
could,
is
you could
somewhat a
dance
bit more
around.
like this. This is not the most dignified way to do science.
Beautifully.
This is probably why I had to leave science.
Beautifully delicate.
Yeah.
But you see, the point is that it's a very complex system. Because of all these slightly different orbital inclinations, then it's relatively easy to predict when the eclipses are, but they're not as you'd expect, unfortunately, I suppose, in many ways.
Because it is something that
Every
people
month.
are always very struck by, because how we can, to the nearest minute, predict these kind of things. It's one of the things people always
high
want to know.
precision.
How do you do it? I mean, is it a clockwork universe? How do we know it's going to happen at this morning at that precise time?
Well, I can tell you that in the rest of 2011, there will be 3 partial solar eclipses. The first will be on June the 1st in Siberia, and it will begin at exactly 7:25 and 18 seconds. That'll be closely followed by another partial eclipse, which will be visible across the Antarctic Ocean on July the 1st. And the final partial solar eclipse of the year will be on November 25th, and it will be visible from New Zealand. Now, I'm going to show you exactly how we can predict that. Well, to work it out, you need to know how the Earth spins on its axis. You need to know the precise details of the moon's orbit around the Earth and how the Earth orbits around the sun. And then you throw in a bit of mathematics and a bit of physics, and you can work it all out. It's simple. But how did we know the positions of all these celestial objects in the sky in the first place? To show you, I need to get out to the clear skies of the countryside. This is Glastonbury. With a history stretching back thousands of years, people have come here to gaze at the stars. Each of those stars acts as a landmark. Plot their positions, and you can work out exactly where the Earth is in space. Now, if I was to ask you what are the stars, and you knew absolutely nothing, then you might say, well, they're just points of light attached onto a giant sphere surrounding the Earth. But that's not as ridiculous as it sounds, because if you just take a casual glance up, then they look like they're just fixed, shining in the sky. But if you look a little bit more closely, then you'll see that they're not fixed at all. They're gradually rotating around in giant circles. But it's not the stars that are moving, it's us. The Earth is continually spinning. You can't see it by looking down, you only notice it by looking up. I can show you that the stars appear to move across the sky by just taking a picture. Now, I'm not taking an ordinary picture because I'm leaving the shutter on the camera open for 10 seconds. You see, the stars now don't appear as points in the photograph. They appear as streaks or lines. And that's because during the 10 seconds that the shutter was open, the Earth has rotated by quite a large amount below the night sky. And so the stars have left a trail behind them. If I were to stand here all night which I'm not going to do because it's freezing and blowing a gale, then after just 4 minutes, I would see that the stars had moved around 1 degree across the sky. If I were to stand here for 12 hours and still be alive, then they would have moved 180 degrees across the sky. And if I came back at the same time tomorrow night, so 24 hours later, then the stars would have completed one complete 360-degree rotation around the sky. By looking at the stars, we can work out exactly which point of the night it is as the Earth spins on its axis. But that's not the whole story. The position of the stars don't only tell you what time of day it is, but also what time of the year it is. It's too cold up here, so I need to go somewhere a bit warmer to explain. Today you only need to look in a diary to find out what month it is, but you couldn't do that 2,000 years ago. Back then, they knew the date because it was written in the sky. If you know which stars are in the sky every month, then you have a very simple calendar. This is the sun, and this is the Earth, and this is the Earth's North Pole. So when the Earth is here, the North Pole is tilted away from the sun, and this is Northern Hemisphere winter. And this is also the night, and this is the day, because the sun is in the sky over here. So when you look out at night, you see the stars that are over in this direction, constellations like Orion and Gemini. Now, as the Earth moves around in its orbit, so to here, this will be Northern Hemisphere spring. Now, that's the night, and this is the day. So you see the stars in that direction, constellations like Leo and Virgo. The Earth carries on its orbit. This is Northern Hemisphere summer. This is the night, and you see constellations like Sagittarius. Then the Earth continues in its orbit again, completes one full cycle, 1 year. You're back to the winter stars again over there, constellations of Orion and Gemini. Watching the apparent movements of the stars and the moon, which takes a little under a month to orbit the Earth, means that we can chart precisely where we are in relation to the sun at any time. So the whole sky runs like clockwork, and we understand that clockwork precisely because it behaves in perfect accord with Newton's laws of gravity. So we can predict where anything will be at any time, thousands and thousands and thousands of years into the future, with such precision that I can tell you that the next time the moon moves in between the sun and the Earth and casts its shadow over the United Kingdom will be on the 23rd of September 2090, and that total solar eclipse will last for a maximum of 2 minutes and 39 seconds.
So is it only since Newton wrote down his laws of motion that we were able to talk about this clockwork universe?
I mean, you would think so, wouldn't you? But actually, ancient civilizations were able to predict eclipses pretty accurately for thousands and thousands of years, even before we knew that the Earth went around the sun and the moon went around the Earth, because it's just cyclical in some sense. There's a thing called the Saros cycle, which says that eclipses only come round every 18 and a third years. So you can use that. But actually, even now, we can't predict them with absolute precision, because even if you only have 3 things orbiting around each other, so if you only had the sun, the Earth, and the moon, irrespective of anything else, you can't solve Newton's equations precisely, but even 3 things, it's called a 3-body problem.
Yeah.
So the solar system's a little bit chaotic, chaotic by the strict definition.
Yeah, so it's probably mildly. Okay, Graham, we'll come back to that later. Liz is standing by at the moment, however, with a team of astronomers ready to image the sun for us.
Thank you very much, Dara. Now, it is worth pointing out that it's incredibly dangerous to look at the sun with the naked eye or with a pair of binoculars or a regular telescope. Please check out our website to make sure you get some tips on how to do all of this safely. Now, check out our beautiful array of equipment that we've got here to try and get some beautiful images of our star for you tonight. First up, look at this telescope. This is Andrew. Andrew, tell us the story of this beautiful piece of kit.
This is a handmade 90mm apochromatic refractor.
When you say handmade, did you make this yourself?
Yes, I did.
That is very impressive. And what's the optical quality on this then?
About as good as it gets.
Really? Can I have a quick look at what you're getting?
We've got a camera set up here, and we've got...
Wow, look at that sunspot.
Yes, we've got a nice sunspot this morning. You can see the umbra, that's the lighter area
Yeah.
around, and the darker inner structure, the umbra is
The
there.
detail is spectacular. Well, how about you knock me one of these up for the end of the show, except maybe in blue for me?
No problem.
Excellent. Thank you very much, Andrew. Now, just to give you an idea that, you don't have to have a high-tech piece of equipment like this. This might look a little bit more familiar to you. And this, I kid you not, is Sunny. I'm not making that up. Sunny, thanks for joining us. Now, talk me through this then, because this looks familiar.
So here we have, hidden behind our mask, a DSLR camera,
Grand stuff.
telephoto lens,
Yeah.
and inside a very special filter that blocks a lot of that.
And
that
that's the
bright
clincher
light.
here. Most people may have a lens like this, a camera like this, but it's all about this filter for safety and for imaging the sun beautifully. Can I have a look at what you're
Absolutely.
guessing? Fabulous. Look at how gorgeous that is. Excellent. So you're capturing some of these images for us for the end of the show. Thank you very much, Sunny. And now come with me because actually this is my personal favourite. It's called a sun spotter, and this is Daryl. Daryl, talk me through this then.
Sure, this is a nice simple solar telescope.
Yeah.
It has an objective lens and some mirrors and another re-imaging lens that projects an image of the sun onto paper down below. It gives a nice big sharp image of the sun. You can see a sunspot on there.
It's absolutely beautiful.
Simple and elegant.
Yeah, I'm very impressed. So it just goes to show you don't need to have totally top of the range high-tech equipment. You can image the sun beautifully with fairly simple equipment.
Yes,
Thank you, Daryl. Now,
definitely.
Daryl is actually here for another reason because Daryl just happens to be the chief observer at the Solar Observatory at the top of Mauna Loa here on the Big Island, and he captures some stonking images of our sun and all the solar activity going on its surface. So come back to us soon and we'll show you some of those.
Thanks, Liz. Now back to Dara in the same room as me.
Thank you very much. You're getting really slick at this. You're getting really polished. Okay, while Liz and her team are taking this image, let's find out a little bit more about the sun.
Our sun was born about 4.6 billion years ago. For all that time, it has been the anchor for the planets and other objects in our solar system. On Earth, the third planet from the sun, it is the giver of life, driving the seasons, the ocean currents, the weather, and our climate. This colossal burning sphere is more than 1 million times the volume of our planet. It makes up 99.8% of all the mass in our entire solar system. It's made of scorching hot plasma, and its energy is created by nuclear fusion reactions that occur deep inside the sun's core. This energy reaches the Earth as light. To us, the light from the sun looks yellow, but sunlight is actually made up of all the colours of the spectrum. From afar, it is a beautiful orb with not a mark on the surface, but modern technology has shown us that there is much more to see. Space probes like NASA's SDO focus on the sun 24 hours a day, photographing the sun in many different wavelengths. This has allowed us to observe never-before-seen details, like the granules that make up the sun's surface, some the size of a continent, and the violent coronal mass eruptions, ejections of gas that rise 60,000 miles above the surface, or the huge black spots known as sunspots, some large enough to engulf the Earth. Space observation has allowed us to track their numbers as they ebb and flow across the face of the sun. The greater the number of sunspots, the more active and more powerful our star becomes. More sunspots also mean more solar flares, bursts of intense radiation that eject streams of electrically charged particles into the atmosphere. From the surface of the sun, they begin an epic journey that will take them out to the furthest reaches of the solar system. They travel past the closest planet, Mercury, past Earth, Uranus and Neptune, and beyond to the furthest objects in the solar system, like the dwarf planet Sedna. Its influence only wanes deep into interstellar space, when our sun becomes just another star in the vast canvas of stars that make up our extraordinary galaxy.
Yes, the sun is just another star. We, however, have been let down here. How are you, Mark?
Hello there.
You couldn't supply us any clear sky at all?
No,
That's very
we've
good,
got some amazing cloud displays over there. We've got
Yeah.
some stunning ones over there, and we've got aeroplanes and all
When
sorts of
nature,
exciting
when
things.
nature lets you down in spring watch, they use stuffed animals. It's all puppets. The real
What are you saying?
the real Bilotti escaped into the wild about 10 years ago. They've been using the puppets for that long.
No, but we've got the stellar equivalent of a stuffed puppet, haven't we, from last night?
Yes, a star we recorded
Which is
already.
Sirius. We had a
Yes.
great image of Sirius from last night. You're absolutely right. And it's a star that's about 8.5 light years away.
Now, is that the brightest star in our sky?
Yes, it's the brightest, but it's not the closest, is it? Proxima Centauri is the closest star, about
Yeah,
4
about
light
4
years.
light years. Yes, it's one of the closest, one of the top 3, I think. Which is ridiculous when you talk about the word close.
Yeah.
In terms of
If it takes
8.6 light
light
years.
from the sun to come, it takes 8 minutes to come from our sun. How long does it take to come from Sirius?
So just over 8 years. So you did the
8
maths.
years. Oh my lord.
How many times
360 times by 24.
It's a big number.
Yeah,
It's a big
yeah,
figure.
yeah.
But the crazy thing is, if you think back 50 years ago, we didn't know about lots of these things in the universe. We didn't know there were planets outside our own solar
Of course we
system.
did. Oh, outside the solar.
Outside the solar system.
Right,
We
yeah.
never knew they
Yeah,
were
we
there.
covered
I call you out there. But now we know there's about 500 of them.
Yeah, 500 planets around other stars, and they're
Other
just the
stars.
ones we can see.
And that's just an incredible thing. It's mind-blowing, isn't it?
Yeah, absolutely.
And certainly when you
Stunning.
think about, looking up at the sky, people forget, I think, that the stars are just other suns. And that is really quite an incredible thought.
Okay. Well, even in the absence of clouds, what would be your tip for?
Well, I think the important thing, when you're trying to find your way around the sky, the important thing is to have a point of reference that you can kind of orientate yourself with. Now, that sounds an easy thing to do, and it sounds perhaps an easy
It's
task
difficult
to
because
try
they keep moving those
Well, they do
things.
keep moving. It makes it so much harder. Now, it sounds like an easy task to show someone how to find your way around the sky. But as I found out when Jonathan Ross is your pupil, it's actually not such an easy task. Last time I met Jonathan, I found out why he'd never used his expensive telescope.
Oh my God, this is it.
This is my telescope.
This is your pride and joy. Why have you not used that part?
Because it's difficult. It's too hard. It's quite hard.
So I took him right back to basics.
The eye.
I've done that.
Let's go outside.
You just use the naked eye.
Outside.
What's the point of having you if you're just going to... I could do that on my own.
There we have it, your first ever live view of Jupiter, the king of the planets. God, that's incredible.
Well, it's not incredible for you. You've done this before, but it's incredible for me.
Well, that went well. Now Jonathan's seen his first planet, what about a crash course in constellations? Now, there's something you need to be able to see around the sky. Any idea what it is?
No.
No. A
telescope.
A telescope helps. Two things. One is one of these little gadgets called a planisphere. And another thing is a point of reference in the sky. So we'll come back to this. Right. The point of reference that we use is the plough. Do you know where the plough is?
I know it's above us somewhere.
Yes, it is. Any idea where? Okay, I'll give you a clue now.
That doesn't look like the plough.
No.
That's the plough.
No.
That's near
You're
the
heading the
plough.
right way. You're getting warm.
There.
Bit more.
Over there.
Just a hint. Keep going.
Just about over there.
Just right there. Spot
That's
on.
it there.
So you do know where it is. Now, the plough is very useful because it's always up in the sky, so we can use that as a reference point to find our way around the sky.
So is that what sailors did?
Yes, it is, exactly. The two stars, you can just see the two front stars in the bowl, called Marek and Dubhe. They point up to the pole star, due north.
Is that it there? Is that the pole star?
Yes, that's the pole star up there. So we use the plough and we can find anything in the sky. Now,
Your dear friend?
my dear friend, the planisphere.
Wow, look at that.
Now, the planisphere is a really useful bit of kit. It's really cheap as well.
How much would this go for?
£5. Wow. Not much at all. You need to set the date and time around the outside. You can see there's two plastic
So it's a bit like a
discs.
sideboard in that respect.
Yes, it is. If you take control of that, what you need to do is align, the current time is about 10 o'clock, which you've got 10 p.m. on the side there.
So where do I line that with?
10 p.m, align it to December the 8th.
There?
Whoa, that's it, stop. So that now shows you the sky as it is tonight.
Wow.
Now all you need to do is hold it up above your head with the end marker pointing due north. So you hold it up like thus, and that is how the sky looks tonight.
Is that due north?
That is due north. And we know that from finding the pole star.
Oh, I see. That's why we bothered with the whole pole star business.
So that now
All
shows
right, Mark,
you...
forgive me. I thought you were just showing off.
So look for the plough and the pole star in the north, find them on the planisphere, and you effectively have a map of every night sky constellation.
Wow.
An easy one to start with is just over there on the horizon, that really big bright one. Yeah. Just there, look.
Is that one?
That's that one, that's Sirius.
Sirius Major.
You can't miss it.
Seriously.
That's what we did there.
Oh,
See what we
dear.
did there. But if you look just above to the right, and you can see it on the planisphere, you've got the plough just down there.
Oh, yeah.
You follow that across.
So this is great.
That takes you to Orion, just over there on your right shoulder.
With his belt.
With his belt. Yes.
Got it.
So we've got that fuzzy blob just below the belt.
Yes.
That's the Orion Nebula, which is a region where stars are forming. And it's
No.
taken millions and millions of years for that gas to be pulled together under gravity, and eventually stars will form. We now scoot back towards the plough again, so twisting round town.
There, the plough, I remember them. That would be the North Star.
That's the North Star. If you
there.
keep following in that direction, you come to a W on its side, which is Cassiopeia.
I suppose.
Or an M, could be an
yeah,
M.
well, yes,
Could be
okay.
an M, could be a W on its side. Sort of. But then if you go a little bit further, the star I'm particularly interested in is the one that's just above the trees.
What, straight up?
Straight up.
Well,
almost.
so straight up, yeah.
That is a star in the constellation of Andromeda.
Right.
Now I'm going to amaze you now, just off that star, and scooting across to the right a little bit, scooting and squizzing, as proper astronomical terms, is a faint fuzzy blob.
I think I see it, yes.
Can you? Do you have any idea what you're looking at?
I know it's going to be something
It's gonna be
impressive.
something
I'm going to make a wild guess.
Go on, have a try.
Either Uranus or Pluto.
Neither.
No. Okay, let me keep going. Mercury.
No. So I'll
Saturn.
put you out of your misery. That fuzzy blob is the Andromeda Galaxy.
That's what I was thinking.
You were thinking that was your next choice, wasn't it? The Andromeda Galaxy is a galaxy outside of our Milky Way galaxy.
No.
It's a distance, get this,
No, you're giving me a headache.
I am 2.5 million light years away.
So how long is that taking to reach us?
2.5 million years for the light to reach. So the
2.5 million
so
years?
the image we can see now was how it looked 2.5 million years ago.
Wow. What is going on there now?
Who knows?
Well, don't we have a telescope
it's
up there?
actually heading straight for us. How does that make you feel?
Makes me look forward to the blissful release of death.
Really? That's
Well, I don't want to be
positive-
here when it
a
arrives.
Positive optimum
It
thought,
comes
isn't
crashing into the earth, people screaming in terror,
gonna crash.
the skin dropping off their body,
Have I ruined your
Terminator
night?
stalking the streets, killing people with his metal
I've
arms.
ruined your night now, haven't I?
Well, you haven't cheered me up. It's cold, and there's a whole planetary system
Heading
hurtling
straight
towards
for
us
us.
at some terrible
Bigger than
speed.
a planetary system.
We need a president.
Bigger than a
We
planetary
need someone like
system.
Samuel L. Jackson.
We can sort it out, but it's going to be a few billion years before it gets here. So don't panic.
Yeah, we're not really sure how much this is really sinking in. We'll find out tomorrow because Jonathan will be up with us live so we can test him out.
Yeah, now Jonathan was talking about the Andromeda Galaxy there, and I want to show you a picture that I took actually while filming my new series out in March on BBC Two, Wonders of the Universe. Sorry, I took it in the deserts of New Mexico actually, but just with an SLR camera, so using the same techniques that Mark told us about yesterday. And this is my image of the Andromeda Galaxy, and you see that it's well, it's a beautiful bright spiral. It's a spiral of a trillion suns. So it's I think it's quite remarkable. It's 2.5 million light years away.
And if they were there, if they were doing what we're doing now there and looked across back at us, would we look like that?
It's a very similar galaxy to the Milky Way in structure. It's probably about twice the size. But yes, that's what the Milky Way would look like from 2.5 million light years away.
That's incredible. There's still an awful lot to be learned about Andromeda, and what we're about to see is a first, exclusively for us. The European Space Agency agreed to use 2 of their space telescopes, the orbiting Newton XMM and the Herschel, which is the largest telescope ever sent out into space to simultaneously image Andromeda.
Let me just say, actually, I wanted to show you the telescopes. This is a touchscreen for all you doubters on Twitter and everywhere else, every social media site. This is really a touchscreen, as you see there, because I messed it up. What I wanted to do was that.
These are the 2 telescopes.
I'm showing you these 2 telescopes. So this is XMM Newton, which is an observatory, an orbiting observatory, which takes images in the X-ray part of the spectrum. So it's very short wavelength light you can't see with your eyes. And this is the astonishing European Space Agency Herschel telescope. Its mirror is twice the diameter of Hubble, and it takes pictures in the infrared.
Now, what the European Space Agency has done is they've brought together a number of these. They've made a composite image of Andromeda in a range of different wavelengths. To explain that, joining us is Mark Kidger from the European Space Agency. This is what it looks like optically. This is what it looks like just looking at it, isn't it?
Yes, exactly. And you can see that there are dark bands there, the central mass of stars there, the satellite galaxy that showed up nicely in Brian's photo.
Let's have a look at the image, will we?
So just these are images. It's not that there are no stars there. That's dust.
That's dust that's blocking the light of the stars.
Okay, fine.
And then I just want to say that I know that you guys, this is real research, and you brought it forward so we could show this image on the show. So it's extremely good of you. The first time we've ever seen it. That is the composite image from these 2 space telescopes.
Exactly. And this image was taken. It was a sum of 4 images, 4.5 hours each exposure. The first one on December 17th, the last one on December 20th.
Tell me about the red swirling here. What is this?
Okay, so what we've got, the red and the orange there, that is the Herschel image. This is dust that's being heated up by stars, young, huge stars, much bigger than our sun, that are warming up that dust. But warming is relative. We're talking about 20, 30 degrees above absolute zero.
But still, this is the dust that creates stars, isn't it?
That's where the stars are forming, the biggest stars in the galaxy.
Star-forming region. And these are the bits you can't see in the optical. That's
you
in
can't
the
see that at all. That is hidden. That's where you see black in the optical image.
And then what about the blue?
And then the blue, these are the X-ray sources. And there are different kinds of sources there. You'll see different colours. These are different types of objects. The very brightest, the biggest ones, they're stars that have died. They're black holes.
Black holes. You can actually see black holes within
You can see the black hole. You can see the material falling into the black hole, being heated, being accelerated, and emitting X-rays.
So that's the real beauty of this image then. You can see glowing black holes, you can see star-forming regions. So with those 2 telescopes, you see a completely different picture of the story of Andromeda.
You see a dynamic, living galaxy. You see the stars forming where it's brightest yellow. That's where the stars are forming. And these blue patches, these are where stars are dying or have
It's an
died.
incredible image, an incredibly dynamic image of what's happening in Andromeda at the moment. But from that galaxy, with 1 trillion stars back to our own, it's a volatile place. The sun constantly spewing out material into the cosmos, and the effects can be dangerous, as Liz found out.
Millions of people were affected by what's being described as the biggest blackout in history. In New York...
Imagine the scene. You're sitting at home when the news starts to come through that the world's biggest cities are being plunged into darkness. Trains aren't moving, traffic grinds to a halt, hospitals can't operate, and all the communications are dead. People are gathering in the streets and rumours start to circulate as to the cause. The TV goes dead. You look outside and all you see is darkness. This might sound like the plot from a bad disaster movie, but it's actually a very real possibility. The world's electric infrastructure is at risk, and it's all to do with this. A coronal mass ejection, otherwise known as a CME. This colossal bubble of a magnetic field filled with charged particles is ejected across the solar system by magnetic storms on the surface of the sun. Usually when they reach the Earth, they have little or no effect, but if big enough, it's possible that a massive CME could turn off all of the world's power with untold consequences. Avi Schnurr is a man on a crusade to warn us all about large-scale CMEs. He thinks we're due a CME that could spell the end of the modern world as we know it.
We now understand that about once per 100 years, there are coronal mass ejections far larger than we've seen in modern times. Food, water, electricity, medical care. That infrastructure will be burned out the next time there is one of these very large coronal mass ejections. Now, the last time this occurred was 1859. This was a CME which at the time burned out the telegraph all over the world. So obviously, if this happened today, we have structures which are far more sensitive than the telegraph network. So we're facing the same kind of problem, but with a society which is far more vulnerable.
So how can invisible charged particles from the sun travel for 93 million miles and still cause so much chaos here on Earth? Dr. Lucy Green, one of the UK's top solar astronomers, has been watching the sun every day for the last 12 years.
When these coronal mass ejections are launched from the sun, what we see is a huge bubble of magnetic field carrying plasma with it. So I mean protons, electrons, charged particles. And actually, each one carries about the same mass as Mount Everest. They are huge structures. Now, they travel through space, and interestingly, when they reach the Earth, what you see is a connection of the magnetic field originating in the sun, in this coronal mass ejection, and the magnetic field of the Earth. And when these two systems link up, we see a whole range of very, very dramatic consequences. It seems like the magnetic field is an invisible force, but actually what it is able to set up through a magnetic connection is the ability for very, very strong currents to flow from the sun to the Earth.
What happens is the coronal mass ejection hits the Earth's magnetic field. The response is these huge ground-induced currents that flows through the big generators, the big transformers, and within a minute, a couple of minutes, you burn out those transformers, the generators, and you've shut down the electric grid.
So, should we all run to the hills, or is there someone out there working to save us? Well, there is, as it happens. His name is Chris, and he works for the National Grid.
Here at National Grid, CME is part of our daily operations. The largest CME that National Grid has experienced was in 1989. We had no problems with that. Our system managed through that. And we gathered a lot of data to get a better understanding of how CMEs affect electricity transmission networks. People at home should not panic that we're going to black out under a CME. We're not designed that way. If we lost one transformer out of the 885 transformers on the network, that isn't going to lead to wide-scale power losses, so people at home should not panic.
So it looks like day to day we're in good hands, but a big coronal mass ejection, an event that last happened in 1859, could push our 21st century technology to the limit. Will we have any warning, and can we tell when the big one will strike?
Looking at the historical evidence shows us that a big event will happen in the future and has happened in many times in the past.
Statistically, we're something like 50 years overdue. It will happen, we don't know when.
The experts may not know exactly when it will happen, but it looks like the very star we depend on for life could give us a lot of trouble in the future. Well, Darryl Coon, our resident solar astronomer, is still with us. Darryl, why is it so difficult to predict when the next big CME might hit us?
Well, CMEs are very complicated. We don't totally understand them yet. There's a lot of solar activity that follows an 11-year cycle, and the next peak of the 11-year cycle is in 2013. So we expect to see a lot more CMEs then.
So you'll be keeping your eyes peeled to the skies on that particular year in particular. So it's when what? The activity of the sun is at its maximum?
It'll be at a maximum in 2013.
Amazing. And, you know, how much activity are we talking about on the sun? Because I've heard of solar flares, I've heard of CMEs. What's going on that surface of our star?
There's a lot of things going on the surface of the star. If you look at this video here, you can see how the sun rotates every 28 days over the course of almost a year. There's a time lapse. There's bright active regions on the disk of the sun, which is the surface. And in those active regions, we get CMEs and solar flares.
Okay. Do we get any warning at all of CMEs, by the way?
We do. After you see a CME, if you detect it, it takes about 1 to 5 days for the mass particles to hit the Earth. So there is a warning system.
So if in 2013 it looks like there's one emanating from the sun, big bubble forming, we can have about a day's warning minimum?
At least a day, yeah.
That's kind of good news. And what's the difference between solar flares and CMEs?
Solar flares are intense release of radiation throughout the spectrum and beyond. And a coronal mass ejection, a CME, is a release of mass.
So there's stuff in there, charged particles in there.
Plasma, yes.
And I've heard about this big three. You've got your solar flares, your CMEs, and your prominences. And you've got some amazing footage of those, don't you, from your observatory? Let's have a look.
If you look at this one, you can see in this clip to the right of the sun, there's a prominence erupting off the sun. And part of it comes back to the sun, part of it goes hundreds of thousands of miles off
that's how high they can reach. It almost looks like a volcanic eruption.
It does. It's very fluid.
Look at it, it's absolutely
It follows magnetic field lines.
Beautiful, incredible. So it is not a benign disk, that sun of ours. It is incredibly active and volatile.
Yes.
Thank you so much for showing us those. They are spectacular.
My pleasure.
And what do you think of our setup here today on the beach?
I think it's great.
Incredible,
nice.
isn't it?
Yeah.
It's a good turnout. Will you be so kind, being the expert and all, to pick sort of your favourite images for us by the end of the show?
It'd be my pleasure.
Excellent. Come back to us for that.
Stuff. We look forward to seeing those images later. Lucy, we met you earlier in Liz's film there. She's quite apocalyptic about stuff. It's not all bad. There are some benign benefits from this activity.
That's right. I mean, the sun does affect the objects throughout the solar system, but it can create beautiful things such as the aurora, the northern and the southern lights.
And we have some viewer photographs of the aurora. What exactly is happening? What's the physics of this?
Right. So when we think about the aurora, we have to discuss currents flowing through the Earth's atmosphere, driven ultimately by the sun and the fact that the sun and the Earth are connected through emissions from the sun. And so I brought this in here to kind of demonstrate it. So in here I've got a gas, which represents any gas, could be the gas in our atmosphere, and if I pass a current through it, the gas starts to glow. So that's what's happening in the Earth's atmosphere. Huge currents, so electrons coming down into the Earth's atmosphere.
But there's atmosphere everywhere. Why the north? Why is it only seen up and towards the Arctic Circle?
Well, it's really to do with the Earth's magnetic field.
Right.
So these electrons, these charged particles, like to spiral around magnetic field lines. And if you think about the Earth's magnetic field, it has a kind of bar magnet, if you like, in the middle, and the field lines converge in the north and the south regions. So that's where the particles come down.
Yeah, I mean, we filmed Wonders of the Solar System in Tromsø in Norway, so right at the north of Norway. I think we've got some of that footage now. It's just really beautiful. And I was prepared to talk about all the things you talked about the Earth's magnetic field. But actually, when I saw it, it was quite a powerful experience. And there's a Norse myth, actually, that it's because they obviously knew well before they understood it that the aurora was there. And they talked about it being the spirits of virgins. Right, which is so unmarried women. It's kind of a euphemism in a way. Who died before they started being virgins, and they were dancing between the space between heaven and earth. And it was very beautiful.
Britain's at the forefront of the research into this, isn't it?
Well, it is. So it's really interesting to be doing work looking at the sun in this country. So in particular, we're interested in where do these emissions from the sun come from? So something like the solar wind, this constant wind that blows out into the solar system.
And it doesn't affect us, of course. Other planets get
No, we've got some pictures, haven't we, of Jupiter, I think, aurora around the pole of Jupiter. I think that's the Hubble Space Telescope image, and aurora around the pole of Saturn, which I think is taken by Cassini.
Yeah. So all of these pictures that we're seeing are ultimately created by the sun. And so in particular, we're using a spacecraft called Hinode and a spectrometer that's on this spacecraft called ICE to try and study where these flows from the sun are coming from. And because it's a spectrometer, we can actually look at how the gases are moving in the sun's atmosphere.
It's very interesting stuff, but contractually we are obliged to now go to a field outside of see where it's cold and see how Mark is doing.
Hello, still here in the wacky, cloudy skies of Macclesfield. We did actually have a glimpse, believe it or not, of a star we saw Capella in Auriga, but as quick as it appeared, it disappeared again. So there's not much to be seen at the moment. But there are clear skies around the country, I'm sure, and something you can look out for is the Great Orion Nebula, which is seen to the southeast, just rising over the southeastern horizon. Looks stunning. It's an area of star formation. You can see it with the naked eye, but point binoculars or telescope at it, and it looks absolutely stunning.
Okay, thank you very, very much, Mark. Now, some questions that were coming in. Lots of people are asking, including, I think, Barnaby from Leicester is one person. Why is it that the moon fits so perfectly over the sun during an eclipse?
It's a complete coincidence. We're the only place in the solar system where perfect eclipses occur. And it's not going to last forever because the moon is drifting away from the Earth every year through a process that we understand very well. In fact, we measure it. We left a mirror on the surface of the moon at Apollo 11. And we bounce a laser off it every night from somewhere in Texas and measure the precise distance of the Earth to the moon. And it's drifting away 3.8 centimetres per year.
So it's the difference in the ratio of its size is
that's right.
Just almost the same as...
It's 400 times less than the diameter of the sun, and it's 400 times closer to us than the sun is. And so it perfectly covers it up at the moment, but in the future, because it's drifting away, you won't get perfect eclipses.
Okay,
it's a transient phenomenon.
Now, several people asking, after last show, why is Pluto no longer a planet?
Pluto is not a planet because there are lots of Plutos in the solar system. We've already discovered one planet called Eris that's bigger than Pluto, but there are many objects in a region called the Kuiper Belt, which is beyond the orbit of Neptune, up to something like 50 times further away from the sun than the Earth is. And there are lots of ice planets, ice dwarfs as they're called, in that region. So if you let Pluto in, you'd have to let another 100, it's like a nightclub bouncer, where it's a cascade of rubbish.
It's just to keep it manageable to a certain extent.
Keep it manageable.
Pluto's still around, Pluto still has an atmosphere, Pluto still has stuff going on there.
And we've got a mission to it. The mission set off to it, which was called Pluto Express. I'm not sure what it's called now, actually.
Yeah.
But it was on its way, and Pluto got demoted after we launched it. So we're still going to go to Pluto, even though it's no longer a planet.
Charlie in Hampshire, very quickly, given that the giant planets are made of gas, can you drop through it?
You can, and we dropped a probe through it called Galileo probe, which is around Jupiter. We crashed it into Jupiter's atmosphere so we wouldn't crash it onto the moon Europa, which may have life on it, and that's one of the reasons we didn't crash, or below the surface anyway, because of liquid water there.
Okay, listen to this. I want you to tell me what this is. Any idea what that is?
That's the start of Star Trek.
It just sounds like
space, the final frontier.
It's made as a bed for a portentous voiceover. No, it's a piece of music apparently composed using the sounds of stars.
Which is nonsense because sound does not travel
through this is what I said as well. I heard about sounds of stars and said this makes no sense. Space is a vacuum, sound can't travel through it.
It's another piece of nonsense. It's like going to that field. We should have carried on talking about your own.
No. Listen, how can we possibly hear what the sounds sound like? Let's find out. Don Kurtz is an astroseismologist, which apparently means he studies the stars by using sound, which, given that they're sitting out there in total silence, means he might as well claim to be studying them by smell. But he's asked me to meet him in a music studio in London because he's got no doubt that this stellar music is real.
There are sounds in the stars, Dara. The sun, which you can see back there,
yes,
rings with over 2 million sounds. Let me play one of them for you.
I'm not saying you're a liar, Don. I'm not saying you've come here with some agenda. But do you mean that if I floated outside the sun and there was gas around me, that I'd hear this?
If you're in the sun's atmosphere, you can't hear the sounds because they're too deep. So we've taken those sounds and we've moved them up into the audible where you can hear them, but we've remained as true to the original sounds as when you do a key change in music. So that's still the melody of the sun.
Okay, it's all very well claiming the sun has a melody, but because there's no atmosphere between us and the stars, the melody can't reach our ears. So how's Don working out what they sound like?
The sound can't travel through the vacuum, but we can see the sound. And I want to give you a demonstration of that. We're in a sound studio. We've got a drummer here. Let's bring him on, and I'll show you how we can see that there's a sound there.
Okay, can we have the drummer? Thank you, thank you. Fine.
Now, he's behind a glass window. We're hearing him through the microphones. And so if I reach over here and turn off the microphone, even though you can see he's drumming, we're watching him do it, but that sound can't get to us. In the same way as the stars vibrate, the sound doesn't come to us, but we can watch the surface vibrate, and we can see that there's sound there.
Okay. Big question, however, is how long do we leave him in there drumming? Because, you know, that guy gets paid by the hour. So even though we can't hear the sounds that stars make, Don is able to work out what each one sounds like by looking at the way its surface moves and vibrates.
All the stars make different sounds. Each one's got its own characteristic sound, just like musical instruments. So, Dar, if I pick up a guitar, and you pick up...
Is a zither, I believe?
You might think if we played the same notes,
it should be exactly the same.
Would sound the same. But if you play a D for me there...
Luckily, D is marked.
Right there. Yes, it is D.
The fact that they have a different tone is down to, the constituent parts of what makes this instrument
It's down to the resonators. Look at the difference in the shape of the resonator on this instrument compared to this one. And so the sound of the guitar is the sound of the shape of this resonator. The stars are giant resonators.
So you listen to the sound that the stars make, and you can track backwards from that and go, well, now I know something about the shape of it, the chemistry of it.
Its magnetic fields, temperature, pressure, everything there is to know about the inside of a star.
Don can even work out what the star is made of. This is because sound travels differently in different substances, so by analysing how the sound is travelling, he can figure out what chemicals are in the star. And he has a neat demo of how it works.
You and I are breathing nitrogen and oxygen right now, which are pretty heavy gases. If we were breathing a very light gas like helium, and I happen to have some helium here, and if I breathe my lungs full of this helium,
and then speak, my voice will go up by a factor of 3 because the speed of sound in the lighter gas is 3 times higher.
When I look at a star and measure the speed of sound in it, I can measure the temperature inside the star, I can measure the chemical composition. Will my voice ever go back again? This is a problem.
Well, a serious scientific question is this. By simply listening to the star, you can understand what gases are within the middle of the star.
Isn't it weird that helium seems to make my Irish accent more pronounced? I sound even more like a cartoon Irishman than I do. I'm going to try that again. But before we both collapsed from a lack of oxygen and the stars got subsumed in silliness, it was time to get back to the point. Don had one last mind-blowing insight for me. By studying the sounds of the stars, he's been able to work out the future of our own sun.
When it's old, it will blow away its outer atmosphere, and the core that's left behind will collapse to where it's only the size of the Earth. It will be made of nearly pure carbon, and we long ago calculated that when it gets old, it will crystallize into a diamond the size of the Earth.
A diamond the size of the planet we're on at the moment.
We have now found a star that has got vibrations in it that let us test whether it's got a diamond core, and let me show you that. There's an artist's impression of one of these white dwarf diamond stars as it would look if you could do a cutaway and see inside it. And so when you think of that poem, Twinkle, Twinkle, Little Star, How I Wonder What You Are,
like
up above the world so high, like a diamond in the sky. We now not only know what the stars are, but with the sounds we can see inside, and we actually do know that the sky is full of diamonds, but diamonds the size of the Earth.
Now, there are many ways that we know how stars work. You can see stars being born, dying, and even after they've died in the form of pulsars. Now, this is the thing that Jodrell Bank is most famous for studying, pulsars. And Tim O'Brien joins us from Jodrell Bank now. Tim, thanks for joining us. First of all, what is a pulsar?
Well, the name comes from pulsing, and it means actually in this case flashing. So it's an object in the sky that flashes. Now actually what it is the collapsed core of a star that's exploded. So when the outer parts of the star are flung out into space, the middle of it collapses under its own weight.
Give us some sense of how big these things are.
Yeah, they're actually, I mean, amazingly, these things weigh about as much as the sun, but they're only the size of a city. They're about 20 kilometres across. They're like squashing the sun down to the size of Greater Manchester.
Now, you said about an explosion. What is the explosion? Tell us more about that.
So the explosion is a thing called a supernova. So in fact, yeah, when the star runs out of fuel at the end of its life, the inner part collapses under its own weight, and the outer parts are flung off.
I've got a picture, actually. I've got a picture of the most famous one, probably, which is the Crab Nebula.
Yeah, so this star exploded in 1054. It was spotted by Chinese astronomers as a bright star, even visible in the daytime sky, and that's what it looks like now.
And it's about, what, 6,000 light years away or so?
Yeah, it's about 6,000 light years away.
But can you see that?
Is the remnant of the star in the middle of that? And is that all just...
So in fact, the core of the star is actually that little white dot right in the middle there.
I think the most remarkable thing that Jodrell can do, I mean, it studies them in detail, but it can make an audio recording of them.
Yeah,
so we could hear that, actually.
And why does that sound like a drill or something?
So this thing's a thing called a neutron star. It's spinning round, and it's spinning round 30 times a second, and radiation is shooting out of its magnetic poles. So you get like a lighthouse effect. So as it spins, you get flash, flash, flash. And this one spins 30 times a second.
It's worth reflecting on that, actually. It's a star the size of a city spinning around 30 times a second.
Absolutely.
What can you use pulsars for? Because I know Jodrell is also famous for finding 2 of them, the only double pulsar system.
Yeah, 2 pulsars orbiting one another, and the great thing about that is it's extreme physics. So you've got 2 clocks orbiting one another in a very strong gravitational field. It's the best test we have of Einstein's theory of gravity, general relativity.
Which I find quite astonishing that these 2. What's the speed of the pulsar, actually? One of them's astonishing.
More than 700 times a second.
700 times a
It's
second.
now the size of a city weighing as much as
It's
the
a
sun.
100-year-old theory that you can test.
We're trying to prove Einstein wrong. We haven't managed it yet, but we'll keep working on it.
It's fascinating, thanks. Now, earlier on in the show, Liz and a band of intrepid amateur astronomers were attempting to image our sun for us live using everything from a handycam to a pinhole camera. Let's nip back to Hawaii and Liz's holiday to find out how they got on.
Pretty sick.
Thank you very much, Brian. Yeah, we've had some pretty amazing images of our beautiful star up there this morning, and we've got an expert to pick his favourites for us. Darrell, you've picked 2 favourites, is that right?
That's correct, 2 that I like.
Okay, talk us through the first one.
Okay, this first one I like because it's taken through a simple telescope and it shows the sun clearly. You can see a nice sunspot in there. And it's done through this digital SLR with a telephoto lens and a simple filter.
So anyone can do it, really?
Anybody can do it.
Yeah. Amazing. And what's your second one that you picked for us
I also like the imaging through this telescope.
Aha, yes.
It's a lot more fancy, but the video imaging on that is very nice. You can see activity happening in real time.
You get a real sense that it's not just this benign orb, it is an active, volatile star, right?
Yes.
Beautiful. Well, Darrell, it's been an absolute pleasure having you along. Thank you so much for joining us. And thanks to all of our amateur astronomers today. They've really come up trumps. That's us for today. We're packing up. We're heading to the very top of Mauna Kea, home to one of the most prized collections of deep space telescopes in the world, standing at 14,000 feet. So we're going to be braving altitude sickness live on television. So do bear with us. It might get a little bit interesting. I'll also be trying to image one of the oldest galaxies, about 13 billion years old, live on television for you. We'll see you then. Bye.
Thank you very much, Liz. Now, a few minutes ago, we went out to talk to Mark in the field, and I was joking about it, like, oh, we got to go to the guy in the cloudy field, right? And loads of you got in contact immediately on Twitter because you saw something behind his shoulder, right? Now, this is what that was a meteor falling. We can show this to you a few times here. While he was talking there, oblivious to this, that.
Was he oblivious? Because he turned up to look at it.
What, do you think he sensed it?
No, I don't actually, because that would be woo-woo, wouldn't it? We don't do that here.
We don't believe in that nonsense, yes. Let's go down to Mark and see if we've seen anything else.
Hello there. I have to admit, oblivious though. I think I'm probably the only person in the entire country who didn't see it. But of course, what it was a meteor from the quadrantid shower. Now you can see that still, that meteors from the shower over tonight. It will still peak. So get out there and have a look. Look due west or due east in the early morning hours, and get out there and try and get some pictures of it for us too. Now remember that image we saw of the Andromeda Galaxy? You can see that clearly in the sky tonight as well, if you've got clear skies, of course. It appears almost directly overhead between the constellations of Cassiopeia and Pegasus. You can also see Saturn clearly in the sky. About 7 in the morning it will be due south. Now, if you've got pictures, details of how to get them to us on our website, bbc.co.uk/stargazing, and please do send them through to us. Now, all of this is dependent on the weather, so to see where the areas in the country are that will be clear, here's Laura Tobin from the BBC Weather Centre with an update for us.
Hello there. Well, there is actually a lot of cloud in our forecast yet again tonight, but I think as the night progresses, a better chance of seeing clear skies developing. This is the latest satellite picture. In the south, through Northern Ireland and Northern England, a few breaks in the cloud, but it will be through Northern Ireland and Scotland later on tonight where we'll have clear skies developing. And up until midnight, that should give some great viewings across Scotland and Northern Ireland for yet again the meteor shower here. Elsewhere, there will be a few breaks. And as we head from midnight onwards, it looks as though yet again Northern Ireland and Scotland favoured to see the best of the clear skies. In the south, a few clear spells, and obviously after midnight we're looking out for Saturn and we're looking out for Venus as well. Venus around about 4:10 and Saturn at midnight 33.
Thank you very much, Laura. Keep an eye out for that. Meteor showers, even as we speak. Don't forget, you are our eyes and ears, so keep those pictures coming in, especially if you capture any image of the meteor shower. Tomorrow night, Jonathan Ross will be here with us at Jodrell, and I'll be proving the world that I've got what it takes to make a great astronaut.
Well, it'll be interesting to see what our guest thinks of that. Major Tim Peake, the first British man ever to be selected to be an astronaut training, will be here to give Dara a hard time. We'll see you tomorrow.
Good night.